melon into this wall. Using my massive muscles, I'm going to attempt to hit into the wall. Wow, what a hit. This is how high it hit on the wall. And now we're going to measure how high it went. Inches, which we will later convert into meters. Now using the time, 1.6 seconds, and then measuring how far from the table to the wall. 130 inches.
So while Diana watches a dumb show, doing nothing, just sitting there not helping her partner out at all, we have to find the angle in which the melon was viciously hit by her massive muscles into the wall. So this is what we have so far. We have the melon on the bench on the left and the wall on the right. Now we know that the melon has a vertical velocity upward, a horizontal velocity to the right, and a total velocity, which was the path it took into the wall. Now, using the measurements we took before of time, equaling 1.6 seconds, the distance horizontal, which we converted from inches into meters, which was 3.25 meters, and the height from floor to the point where it collided with the wall, which we converted into meters, equaling 1.4 meters. Now to figure out V vertical, we have to use the equation VF squared equals VI squared plus 2AD. Then manipulating it for VI, which is VI squared equals VF squared minus 2AD. Since VF equals 0, we can cross that out and we can square root both sides. VI then would equal -2 times acceleration, which is gravity, which is 9.8 meters per second squared, times the distance, which is 1.4 meters, VI, which would then equal 5.2 meters per second. Now to figure out V horizontal, we have to use the equation of VH equals DH over T. Now D equals 3.25 meters over 1.6 seconds. VH then equals 2.0 meters per second. Now to figure out the total velocity in which the melon went into the wall, we have to create a right triangle using the vertical velocity and use the equation A squared plus B squared equals C squared. We then plug it in, so 5.2 meters per second squared plus 2 meters per second squared equals C squared. You can square root both sides, which then equals C equals 5.6 meters per second, which is the total velocity. Now to figure out the angle in which the melon was launched into the wall, we have to use the equation cosine theta equals adjacent over hypotenuse. The adjacent side equaling 2 meters per second, and the hypotenuse side equaling 5.6 meters per second. We then have to manipulate the equation and times it by negative cosine equaling theta. Theta would then equal 69 degrees, which is the angle in which we launched the mountain.